Hey guys, this is Shelby with the Rogers Public Library. Our theme this week for Full Steam Ahead is states of matter. So today I want to talk to you about the different states of matter. So first, matter, that's just stuff. Everything is made out of matter. And so there's a couple of different forms that matter can take. This is a liquid. So liquid is considered a fluid, and what that means is that it'll fit into a container regardless of how it's shaped. It goes to the bottom of the cup, but it also has a surface at the top, right? There's a clear line between where the liquid is and where the air in the atmosphere is. There's another type of fluid called gas, where there isn't clear boundaries. So this whole thing is gas. But if I open up the lid, there's not a clear boundary before the gas in the bottle ends and the gas in the air mixes together. And then you have solids, which do have clear boundaries. So this is ice. I put some orange paint in it just so you could see it a little bit better. And it just sits on the lid. It doesn't sink into the lid and fill it in. So the experiment that we're doing today has to do with both liquids and gases. It's called the Cartesian Diver. It's named after a French philosopher named Rene Descartes. He's famous for some other stuff as well. You might have heard a quote that he said called "I think, therefore I am." Well, that's the quote. It's not called that. But what you'll need is a bottle of water. I'm using a 2-liter bottle just so we can see things a little bit better, but you can also use a bottle like this if this is what you have. And you're going to need a bendy straw. So what I've done is I've cut this around the bendy elbow, so it's about the same length. And then I have a paper clip. I have a washer. So it just so happens that when I put the paper clip on the washer like this, and then I put this on the wrong side. When I put the paper clip on the washer like this, and then I put either end of the paper clip into the straw, it will float pretty well in water. So it's just barely tipping out. And that's what we want for our diver. That's what this is called, a diver. And we're going to make it dive. So I'm going to put it in the bottle of water, and I'm going to put the lid back on. That's the most important part, because if you don't, then water just goes everywhere. Let's watch. It sinks to the bottom as soon as I squeeze the bottle. So now we're gonna talk a little bit about why this happens. So it turns out that all gases, or most gases, behave pretty similarly, regardless of what they are. So you might know, or you might not know, that the air in the atmosphere is mostly nitrogen and oxygen. Those are elements, and there's a couple other things that can be in there in smaller amounts, but that's the two. But we could have pure oxygen or pure nitrogen, and if it was at like a regular temperature or room temperature, we could treat it the same way and say it has basically the same physical properties. So what we can think of gas as molecules trapped in a container, and they fill out the container just like this. So we can say we're representing these with marbles. We can say each marble is a molecule of gas. And then there's some other properties that gases have too. So we can say that the volume of the gas is the shape of the plate. And we can put all these marbles into a bigger plate, and it's a bigger volume, but it's the same number of molecules. And what changes between the two container sizes is that if you have more the same amount of marbles in a bigger plate, then when they move around constantly like this, it takes longer for them to hit the side of the plate. And what that tells us is that there's less pressure in this plate than this plate, right? If you have the same number of molecules in a larger container, those marbles will hit the sides of the container less. And how often something hits the side of a container tells us its pressure. So this is gas, right? And this is liquid. The main difference between these two, we said that one fills and one has a surface. This liquid has a surface. is that you can compress gases, but you can't really compress liquids, or at least most liquids like water, very much at all. So I can squeeze the bottle and it crushes, right? But I can only squeeze it so far. But I can't do it with this bottle. I can just barely squeeze it. So what's happening? I'm decreasing the volume, right? So it's the same number of molecules, and they're moving into a smaller container. So now the pressure is greater, and eventually it gets to the point where the pressure is too much for me to make the bottle any smaller. But we actually, we can. If we take the lid off, we can see it'll depress a lot more. So what does this have to do with the little guy? Well, remember that it's a bendy straw, right? So when we put it in the water, there's actually air trapped in there. And when we increase the pressure on the bottle, that actually decreases the volume of air in the thing, and that changes its density. So density determines whether something floats or sinks. And so I'm gonna do this here. I'm gonna pour some water into here. So what do you think is more dense? Do you think water is more dense, or do you think air is more dense? Well, for starters, if we look at this, we can see that all the water is at the bottom of the bottle, and then there's air up here. We think there's air up here. And we flip it over, and now it's at the top. It won't change. So that tells us that air is less dense than water, that it floats. So when we change the water, when we decrease the volume of water, what happens is that it's no longer, the diver right now, it floats, right? We showed it in here how it floats. But when we decrease the amount of air in there, it no longer floats. And actually, part of what's happening is that there's a little bit of water moving into the straw. And we can see that better if we use this. Let's see. This is not very dyed. I'm going to get some other water. This is a very rich red color, so we're going to be able to see it a little bit better. But what we should see is we're going to put both divers in here, right? And now when we squeeze, we see there's water that's going into the eyedropper, the second diver that I put in there, and then water escapes when I let go. So that shows you that water is coming in and water is coming out as we increase the pressure. So that's the relationship between the volume and pressure of water. There's also a couple other things going on, and we talked about density. That's, whether something floats. And then one thing that I haven't directly mentioned, but that we can see from this is something called Pascal's law. And that's that if you change the pressure at any point on a fluid, it actually changes the pressure everywhere. So when I'm just pressing the water on the outside of the container, but that makes the pressure in the entire container change, not just one part. Okay, and so now for our craft. So for this craft, we're going to be using strings, preferably absorbent ones, and water with food dye to make interesting patterns. So this is just some kite string. You can also use white yarn or colored yarn too. It won't actually affect the absorption of the liquid. I'm just going to drop these in the cups, right? One thing to keep in mind with this, you'll notice that I'm using red, yellow, and blue. These are primary colors. So you probably know that you can add colors together to make new ones. So for instance, if you add blue and red together, you'll make purple, or green and or blue and yellow, you'll make green, and stuff like that. So doing this, we should be able to make orange and purple and green if we put the strings together right. And if we don't, it'll end up looking a little muddy, but that's just part of the process. So I have my blue string. You guys might want to use gloves for this, just so you can avoid getting food dye all over your hands. So, but it's optional. I'm obviously not doing that. So we have string 1 and string 2. Gonna put the red over here on the side of the blue, and I'm just hanging the edges of the string over the paper so that we're gonna be able to pull them out, because that's how how the project goes. So yeah, we have these strings. They're coiled up on the pieces of paper. And now we're going to fold it in half. And you'll notice that underneath I have a piece of cardboard. We're going to take the second piece of cardboard and we're going to set it on top. And that's just so that there's some pressure while we're removing the strings, and they don't just slide out. And it's going to produce some cool patterns. You can also use a book for this if you have an old notebook or something that's that you want to, but we're a library, so we don't use books for like that. So I'm gonna pull that one out, pull this one out, and now this one. And if I did this right, then hopefully we should have some new green and purple colors on here. So what did we get? So you can see our patterns. You can see where the strings were laid down, and there is a little bit of green and purple over here and over here and over here. And so yeah, so we have cool patterns. You notice they're symmetrical, right? So the same patterns are over here as over here, with the caveat that I dripped some food color onto the page, so there's some splotches. You can actually do this more than once. If you want to add some extra color to it, you can dip your strings again. You also don't have to use primary colors. I just thought that if I did, it would be less likely that I would make my paint get muddy. But as you can see, it is a little muddy. Down here, it's a little purple, it's a little muddy. But that happens. So that's our craft. I hope you guys had fun. I'll see you next time.